right, welcome back. So with the first video, we were looking at deductive and inductive reasoning, and we talked about the difference between a conclusion and a conjecture. Remember, conjecture is a type of conclusion, but it's based using inductive reasoning, and it can be a false statement. Okay? Then we practiced using our inductive reasoning to find the next number in a pattern. So we wrote a conjecture on what we thought the next number would be based on our observations using inductive reasoning. And then we looked at an activity where we connected dots and looked at how many regions were formed. And then we wrote a conjecture about what we thought would happen if we had 6 points. Okay? And then I went ahead during the break between the two videos and I went ahead and sketched my segments, and I made sure to use a ruler to make sure that I have really good, accurate information. Because if I don't use a ruler, sometimes I don't see all of my regions. Okay, so now I'm going to count, and I'm going to put little dots so I make sure I don't forget anything, and I actually might even number. I'm going to put a number 1 inside this one region here that's really hard. If you're not sure, if you tried this on your own, if you were able to print out the notes, and you're not sure if you've connected everything, if there's 6 points, then each dot should connect to 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Then you know you've connected every dot to every other dot because there's 6 dots, so each dot should connect to 5 other dots. Okay? I'm going to put a 1 in this one because I'm not going to be able to fit any other number other than 1. So that's 1 region. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So there's actually 31 regions, and we conjectured that we would have 32. So when it says, is this the number from our conjecture? My answer is no. It is not the number from our conjecture. But remember, that's okay, because a conjecture can be false. It's still a good conjecture because it made sense to go, oh, 2, 4, 8, 16, 32, multiply by 2. But in this case, it happens to not work. It's a good conjecture, but it's a false conjecture. It's based on good reasoning, but it's false. Okay? Because our conjectures are based on inductive reasoning, looking at patterns and observations, they can be good conjectures, but still be false. It only takes one example to prove a conjecture wrong. So here, this example proves this conjecture wrong because it has 31 regions, not 32. So it proves our conjecture false. It just takes that one to make us wrong. Okay? That one example is called a counterexample. A counterexample is a specific example that proves a conjecture wrong. Okay? So this picture right here, a counterexample can be a drawing, it can be a sentence, it can be an equation, anything that is specific and proves a conjecture wrong. So this diagram right here is a counterexample to this conjecture. Okay? It needs to be a specific example that proves a conjecture wrong. So when we look at counterexamples, the first one we're going to try to find a counterexample for is a shape with 4 sides is a square. Okay? So that means I need a shape that has 4 sides because the first part needs to be true, but then the second part needs to be false. So we need a shape that has 4 sides but is not a square. So maybe, how about a trapezoid? And you can either write it out or you can sketch a picture. So I could sketch a picture. Now, is that the only counterexample I could have given? No. I could have said, what about a long rectangle? right? Because a long rectangle won't be a square because the four sides wouldn't be equal. My length would be longer than my width, okay? What about like a diamond shape, right? It would have four sides, but it would not be a square if my corners weren't 90-degree angles, okay? So anything that has four sides but is not 90-degree angles and equal sides would be a counterexample to number 1. A shape with four sides doesn't have to be a square. I only need to draw one counterexample. There's lots I could give, but I only have to give the one, okay? Number 2 says all angles greater than 90 degrees are classified as obtuse, okay? So I need a specific example that is not, okay? So I can't really just necessarily, it's hard to say like a reflex angle because it's nicer if you can give a specific example. The easiest one I can think of, okay, something that is greater than 90 but is not obtuse, because you want the first half to be true and then disprove the second half of the sentence. So think about an angle where there's one ray of the angle and here's the other ray of the angle. So that if I were to get my protractor out and measure that, right, it looks like a line. And so there's really how many degrees here? There's 180 degrees. Okay? That's still an angle, right? But we don't call that obtuse. Do we remember what we call that? This is classified as a straight angle. An angle that has 180 degrees, we don't classify that as obtuse. We classify that as a straight angle. So this, I could just draw the picture, and the picture itself would be a great counterexample, or I could write out the words. The word would be a good counterexample. Okay? Number 3, all angles or angles that share a vertex are adjacent angles. Okay? So that means I'm looking for angles that do share a vertex. The first part is true, but are not adjacent. Okay? So I can think of 2 that come to mind. I could think of angles that share a vertex, but there's another angle that comes between them. So what I mean by that is sometimes you have something that looks like here's a vertex and an angle, and then maybe here's another angle over here. They don't have to be the same size. They could be different. Okay? They both share this vertex, but these 2 angles are not adjacent because there's an angle in between them, right? So this would be a good counterexample. Another counterexample, and remember we only have to give one, but I really like this other counterexample, so I'm going to show it to you also. My other counterexample would be vertical angles, right? Because vertical angles share this vertex, but they don't share a side. So they are not considered adjacent, they're considered vertical. And again, you don't have to give both of those, you only have to give one because it only takes one counterexample. Okay, so you don't need both, you just need one. And again, those aren't the only I could give. There's other things out there I could use. All right, and then the last one here, if the measure of angle if M is a point on segment AB, then it divides the segment into 2 equal halves. Well, I'm just going to draw that picture. Segment AB, M is a point on it. Well, I'm just going to put M way over here. And then I'm going to say that A to M is maybe 1.5 centimeters. I'm just eyeballing that. And maybe this one is 4 centimeters. So M is a point on segment AB, but it's not dividing the segment into 2 equal halves. This side is way smaller than this side. So this picture is a counterexample. Is that the only one I could give? No. I could choose any sorts of values here as long as they're not equal, and that would be a counterexample to the sentence. Okay? All right, so that is inductive reasoning and counterexamples. In the next lesson, we're going to look at deductive reasoning. Today we just focused on inductive reasoning. Thank you so much for watching.